Hello, my name is David, and in this video I will be configuring a small VoIP network with two Cisco routers running CME and two virtual machines with CIPC softphones. Each softphone will connect to one of the routers, and then I will make a call between them using dial peers to enable communication between the routers. But first, I will make a brief explanation of VoIP. So VoIP stands for Voice over Internet Protocol, and it transmits calls over internet mediums such as Wi-Fi or Ethernet rather than dedicated phone lines. In order to use VoIP, you need a phone that supports VoIP protocols. In this scenario, I will be using Cisco IP Communicator, or CIPC, which is a software that can function to make calls over VoIP without a physical phone. The other component that is necessary for a VoIP network is a PBX, or Private Branch Exchange. A PBX routes and switches calls between IP phones and typically also provides several additional features such as class of restriction, which can control which numbers a phone can send and receive calls from, call forwarding and transfers, call parks, intercom, music on hold, and more. In this video, I will be using Cisco CME, which is a service that can be enabled on certain Cisco routers. It supports less features than a dedicated PBX system such as Cisco CUCM or Asterisk, but could be more cost-effective for small businesses. As it doesn't require extra hardware, it can just be enabled on a router that you might already have in your network. Alright, so now I've got my two routers open in these terminal windows here, and I'm just going to do the basic configuration on these. So, first of all, I'm going to set a host name so that I don't get them mixed up. Just going to call that one R1. And this will be R2. And next, I'm going to set the IP addresses on them. So this one's going to be 192.168.5.6. And it's going to have a subnet mask as well. Just your standard /24. And router 2 is going to be 192.168.5.7. Next, I'm going to configure NTP. NTP is important for VoIP because you want to make sure that all the clocks are synchronized so that the calls don't get out of sync with each other. So first of all, we're going to do clock time zone, PST -8. And then we have to configure an IP route so that this router can actually reach the internet. And the gateway for this network is just going to be the host machine's IP address of 192.168.5.1. And then we also have to configure DNS. So we're going to be using OpenDNS here with Google as a backup, and then enable IP domain lookup. And now finally we just enter the NTP server time.nist.gov and do show clock to verify the time. Looks like it's correct. I'm going to also do show NTP associations. And we can see that we're connected to a server there. Now we do the same thing on the other server, or the other router, rather. Although it's essentially acting as a server in this network. Alright, just verify that one more time. Oh my god. gosh. There we go. All right. So next, gonna enable the telephony service. This is what's gonna make it actually turn into a PBX. So we just have to type telephony-service, and now we can start configuring the VoIP. So first of all, we're going to enable ePhone registration. This just means that IP phones will actually be able to register to the PBX so that they can get a designated number and start making calls. For this environment, we can just set max ePhones to 1, because we're only going to have one phone on each server, but typically you would set it to however many phones you need. And same with the max DN. We also only need one of those, I believe. Again, do the same thing on the other router. ePhone registration. That's not how you spell that. Max ePhones 1 and max DN1. Okay. Next, we're going to set the source address for VoIP traffic. So this is just telling the router where the VoIP traffic is going to be coming from, like which interface on the router. So we're going to do IP source address 192.168.5.6 port 2000. And then on this one, we're going to do the same thing, but with router 2's IP address. And the port can be the same on both of these. I'm also going to set a system message. This will show up on the phones once they've registered to the server, and it just lets me know that everything has registered correctly. So I'm gonna put the name of the router in here so I can make sure that the phones have registered to the right router. And next, we're going to do create CNF files, and this is just going to generate config files for the telephony service. Should be okay because it is actually using NTP. All right, now we're going to go over to the Windows VMs and configure the CIPC application. So I actually haven't installed it yet. Just going to do that quickly.
A few moments later.
Right, now to configure the phones, we have to right click and go to preferences here. And then, no, it's not that one. We're going to go to TFTP servers and set this to be 6 for CIPC 1. So it's pointing to router 1. And then this one, going to preferences, network, use these TFTP servers and set this to 7. And these should register. And if we open up, we should see, yep, the first one has popped up here on router 1. Should see that one showing up on router 2 in a moment. There we are. Okay. So the soft phones have now registered to the routers, and now we can continue on with the configuration. So first of all, we're going to create some DNs. ePhone DN 1 on router 1. The number is going to be, hold on. 7876 for the first phone. And I'm going to set the name to just be my name. On the second router, I'm going to also make ephone DN1 with number 7976. And the name for this one, I'm going to set to skills exam. So this is the name of the phone, or this is going to be the name for the user with this number, essentially. Now we configure the ephone that the DN is going to be attached to, and this is basically the representation of the IP phone in the PBX. So this is how you're going to apply settings to this particular phone, like the phone number or, for example, core lists and that sort of thing. So for the MAC address, 0800, we're going to use the SEP number. This is the MAC address of the IP phone that's registered to the server. I'm not sure why we got this unregistered message, but I'm just going to continue. And for the purposes of this lab, I'm going to be mapping the DN to the second button on the ephone, but normally you would not do this. Normally it would be mapped to the first button. And then let's see if we can restart it from here. That does not seem to be working. I'm going to try manually restarting it. And in the meantime, I'm just going to configure the ephone on the second router. MAC address 0800.2706. Button 2. So button 2 is going to have ephone DN1. That's what this means. And then this one, it should still be connected, so we should see this restart. Okay, the first IP phone has now gotten its number assigned, and you can see it's connected to the second button here. This one is the first one. And okay, so we've got our numbers here, but we're not quite ready to make a call. There's still one more thing that needs to be done. Because right now, the two phones are able to communicate with their respective routers, but the routers don't know how to communicate with each other. So we need to create a dial peer between the routers, and that is going to look like this. Dial peer, voice, and then here you can add an arbitrary number that represents the dial peer in the software. For this, I'm going to be using 7900. The idea is that this represents that router 2's numbers would all start with 79. And then voice, VoIP, that. Then destination pattern. This is, again, very similar. This is where you're setting what the actual number scheme is going to be for the dial peer. So for this one, if I enter a number that starts with 79 and then has 2 more digits, then that is going to be directed to this dial peer. And finally, I have to tell the router where to send this traffic. So we say session target IPv4, and then put in router 2's address. There, okay, no dash. And we do the same thing on the other side, because this is a two-way communication. If you only had the dial peer on one side, then the first router would be sending its traffic over to router 2, but router 2 wouldn't know where to send it back to. So you have to make sure that it's on both sides. So for this one, we're going to say 7800. Destination pattern is going to be 78 ... And then the session target is going to be router 1. And that should be all of our configuration on the routers. So now I'm going to go on here and type 7976, and there it is. We've called our phone across the routers, and now we can answer this call. And all right, so the call has gone through. Everything seems to be working. I'm just going to try one more time calling from phone 2, just to make sure that this is working both ways, and it is. So there you have it.